Internet Business Head Office (BHO), Barack Hussein Obama. The Internet is the global system of interconnected computer networks that uses the Internet Protocol Suite (TCP/IP) to communicate between networks and devices. It is a network of networks that consists of private, public, academic, business, and government networks of local to global scope, linked by a broad array of electronic, wireless, and optical networking technologies. The Internet carries a vast range of information resources and services, such as the interlinked hypertext documents and applications of the World Wide Web, www, electronic mail, telephony, and file sharing. The origins of the Internet date back to the development of packet switching and research commissioned by the United States Department of Defense in the 1960s to enable time sharing of computers. 1. The primary precursor network, the ARPANET, initially served as a backbone for interconnection of regional academic and military networks in the 1970s. The funding of the National Science Foundation Network as a new backbone in the 1980s, as well as private funding for other commercial extensions, led to worldwide participation in the development of new networking technologies, and the merger of many networks. 2. The linking of commercial networks and enterprises by the early 1990s marked the beginning of the transition to the modern Internet. 3. And generated a sustained exponential growth as generations of institutional, personal, and mobile computers were connected to the network. Although the Internet was widely used by academia in the 1980s, commercialization incorporated its services and technologies into virtually every aspect of modern life. Most traditional communication media, including telephony, radio, television, paper mail and newspapers are reshaped, redefined, or even bypassed by the Internet, giving birth to new services such as email, Internet telephony, Internet television, online music, digital newspapers, and video streaming websites. Newspaper, book, and other print publishing are adapting to website technology, or are reshaped into blogging, web feeds and online news aggregators. The Internet has enabled and accelerated new forms of personal interactions through instant messaging, Internet forums, and social networking services. Online shopping has grown exponentially for major retailers, small businesses, and entrepreneurs, as it enables firms to extend their brick-and-mortar presence to serve a larger market or even sell goods and services entirely online. Business-to-business and financial services on the Internet affect supply chains across entire industries. The Internet has no single centralized governance in either technological implementation or policies for access and usage. Each constituent network sets its own policies. 4. The overreaching definitions of the two principal namespaces in the Internet, the Internet Protocol Address, IP address, space and the Domain Name System, DNS, are directed by a maintainer organization, the Internet Corporation for Assigned Names and Numbers, IC. The technical underpinning and standardization of the core protocols is an activity of the Internet Engineering Task Force, IETF, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. 5. In November 2006, the Internet was included on USA Today's list of New 7 Wonders. 6. Contents. 1. Terminology. 2. History. 3. Governance. 4. Infrastructure. 4.1 Service tiers. 4.2 Access. 5. Internet Protocol Suite. 5.1 Internet Protocol. 5.2 IETF. 6. Applications and Services. 6.1 World Wide Web. 6.2 Communication. 6.3 Data Transfer. 7. Social Impact. 7.1 Users. 7.2 Usage. 7.3 Social Networking and Entertainment. 7.4 Electronic Business. 7.5 Telecommuting. 7.6 Collaborative Publishing. 7.7 Politics and Political Revolutions. 7.8 Philanthropy. 8. Security. 8.1 Malware. 8.2 Surveillance. 8.3 Censorship. 9. Performance. 9.1 Traffic volume. 9.2 Outages. 9.3 Energy use. 10. See also. 11. Notes. 12. References. 13. Sources. 14. Further reading. 15. External links. Terminology. Further information, capitalization of Internet. The Internet Messenger by Buki Schwartz, located in Holon, Israel. The word interneted was used as early as 1849, meaning interconnected or interwoven. 7. The word Internet was used in 1974 as the shorthand form of internetwork. 8. Today, the term Internet most commonly refers to the global system of interconnected computer networks, though it may also refer to any group of smaller networks. 9. When it came into common use, most publications treated the word Internet as a capitalized proper noun. This has become less common. 9. This reflects the tendency in English to capitalize new terms and move to lowercase as they become familiar. 9. 10. The word is sometimes still capitalized to distinguish the global Internet from smaller networks, though many publications, including the AP Style book since 2016, recommend the lowercase form in every case. 9. 10. In 2016, the Oxford English Dictionary found that, based on a study of around 2.5 billion printed and online sources, Internet was capitalized in 54% of cases. 11. The terms Internet and World Wide Web are often used interchangeably. It is common to speak of going on the Internet when using a web browser to view web pages. However, the World Wide Web or the web is only one of a large number of Internet services. 12. A collection of documents, web pages, and other web resources, linked by hyperlinks and URLs. 13. History. Main articles, History of the Internet and History of the World Wide Web. In the 1960s, the Advanced Research Projects Agency, ARPA, of the United States Department of Defense funded research into time-sharing of computers. 14. 15. 16. Research into packet switching, one of the fundamental Internet technologies, started in the work of Paul Baran in the early 1960s and, independently, Donald Davis in 1965. 117. After the Symposium on Operating Systems Principles in 1967, packet switching from the proposed NPL network was incorporated into the design for the ARPANET and other resource-sharing networks such as the Merit Network and Cyclades, which were developed in the late 1960s and early 1970s. 18. ARPANET development began with two network nodes which were interconnected between the Network Measurement Center at the University of California, Los Angeles, UCLA, Henry Samueli School of Engineering and Applied Science directed by Leonard Kleinrock, and the NLS system at SRI International, SRI, by Douglas Engelbart in Menlo Park, California, on October 29, 1969. 19. The third site was the Color-Fried Interactive Mathematics Center at the University of California, Santa Barbara, followed by the University of Utah Graphics Department. In a sign of future growth, 15 sites were connected to the young ARPANET by the end of 1971. 2021, these early years were documented in the 1972 film Computer Networks, The Heralds of Resource Sharing. 22. Early international collaborations for the ARPANET were rare. Connections were made in 1973 to the Norwegian Seismic Array, NORSAR, via a satellite station in Danum, Sweden, and to Peter Kirstein's research group at University College London, which provided a gateway to British academic networks. 23-24, the ARPA projects and international working groups led to the development of various protocols and standards by which multiple separate networks could become a single network or a network of networks. 25, in 1974, Vince Cerf and Bob Kahn used the term Internet as a shorthand for Internetwork in RFC 675, 8, and later RFCs repeated this use. 26. Cerf and concrete Louipson with important influences on TCP/IP design. 27. Commercial PTT providers were concerned with developing X.25 public data networks. 28. Access to the ARPANET was expanded in 1981 when the National Science Foundation, NSF, funded the Computer Science Network, CNET. In 1982, the Internet Protocol Suite, TCP/IP, was standardized, which permitted worldwide proliferation of interconnected networks. TCP/IP network access expanded again in 1986 when the National Science Foundation Network, NSFNet, provided access to supercomputer sites in the United States for researchers, first at speeds of 56 kilobits per second and later at 1.5 megabits per second and 45 megabits per second. 29. The NSFNet expanded into academic and research organizations in Europe, Australia, New Zealand and Japan in 1988-89. 30, 31, 32, 33. Although other network protocols such as AOC had global reach well before this time, this marked the beginning of the Internet as an intercontinental network. Commercial Internet Service Providers, ISPs, emerged in 1989 in the United States and Australia. 34. The ARPANET was decommissioned in 1990. 35. T3 NSFNet backbone, circa 1992. Steady advances in semiconductor technology and optical networking created new economic opportunities for commercial involvement in the expansion of the network in its core and for delivering services to the public. In mid-1989, MCI Mail and CompuServe established connections to the Internet, delivering email and public access products to the 500,000 users of the Internet. 36. Just months later, on January 1, 1990, PSINet launched an Alternet Internet backbone for commercial use, one of the networks that added to the core of the commercial Internet of later years. In March 1990, the first high-speed T1, 1.5 megabits per second, link between the NSFNet and Europe was installed between Cornell University and CERN, allowing much more robust communications than were capable with satellites. 37. 6 months later Tim Berners-Lee would begin writing World Wide Web, the first web browser, after 2 years of lobbying CERN management. By Christmas 1990, Berners-Lee had built all the tools necessary for a working web, the Hypertext Transfer Protocol, HTTP, 0.9, 38, the Hypertext Markup Language, HTML, the first web browser, which was also a HTML editor and could access Usenet newsgroups and FTP files, the first HTTP server software, later known as CERN HTTPD, the first web server, 39, and the first web pages that described the project itself. In 1991 the commercial Internet Exchange was founded, allowing PSINet to communicate with the other commercial networks Surfnet and Alternet. Stanford Federal Credit Union was the first financial institution to offer online Internet banking services to all of its members in October 1994. 40. In 1996, Up Financial Group, also a cooperative bank, became the second online bank in the world and the first in Europe. 41. By 1995, the Internet was fully commercialized in the US when NSFNet was decommissioned, removing the last restrictions on use of the Internet to carry commercial traffic. 42. Worldwide Internet users 43, users 2005, 2010, 2017, 2019 44. World population 45, 6.5 billion, 6.9 billion, 7.4 billion, 7.75 billion. Worldwide 16%, 30%, 48%, 53.6%. In developing world 8%, 21%, 41.3%, 47%. In developed world 51%, 67%, 81%, 86.6%. As technology advanced and commercial opportunities fueled reciprocal growth, the volume of Internet traffic started experiencing similar characteristics as that of the scaling of MOS transistors, exemplified by Moore's law, doubling every 18 months. This growth, formalized as Edholm's law, was catalyzed by advances in MOS technology, laser light wave systems, and noise performance. 46. Since 1995, the Internet has tremendously impacted culture and commerce, including the rise of near-instant communication by email, instant messaging, telephony, Voice over Internet Protocol or VoIP, two-way interactive video calls, and the World Wide Web. 47, with its discussion forums, blogs, social networking services, and online shopping sites. Increasing amounts of data are transmitted at higher and higher speeds over fiber optic networks operating at 1 gigabit per second, 10 gigabits per second, or more. The Internet continues to grow, driven by ever greater amounts of online information and knowledge, commerce, entertainment and social networking services. 48. During the late 1990s, it was estimated that traffic on the public Internet grew by 100% per year, while the mean annual growth in the number of Internet users was thought to be between 20% and 50%. 49. This growth is often attributed to the lack of central administration, which allows organic growth of the network, as well as the non-proprietary nature of the Internet protocols, which encourages vendor interoperability and prevents any one company from exerting too much control over the network. 50. As of March 31, 2011, the estimated total number of Internet users was 2.095 billion, 30.2% of world population. 51. It is estimated that in 1993 the Internet carried only 1% of the information flowing through two-way telecommunication. By 2000 this figure had grown to 51%, and by 2007 more than 97% of all telecommunicated information was carried over the Internet. 52. Governance. Main article, Internet Governance. IC headquarters in the Playa Vista neighborhood of Los Angeles, California, United States. The Internet is a global network that comprises many voluntarily interconnected autonomous networks. It operates without a central governing body. The technical underpinning and standardization of the core protocols, IP4 and IP6, is an activity of the Internet Engineering Task Force, IETF, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. To maintain interoperability, the principal namespaces of the Internet are administered by the Internet Corporation for Assigned Names and Numbers, IC. IC is governed by an international board of directors drawn from across the Internet technical, business, academic, and other non-commercial communities. IC coordinates the assignment of unique identifiers for use on the Internet, including domain names, IP addresses, application port numbers in the transport protocols, and many other parameters. Globally unified namespaces are essential for maintaining the global reach of the Internet. This role of IC distinguishes it as perhaps the only central coordinating body for the global Internet. 53. Regional Internet Registries, RIRs, were established for 5 regions of the world. The African Network Information Center, AFRINIC, for Africa, the American Registry for Internet Numbers, ARIN, for North America, the Asia-Pacific Network Information Center, EPNIC, for Asia and the Pacific region, the Latin American and Caribbean Internet Addresses Registry, LACNIC, for Latin America and the Caribbean region, and the RISC's IP Europeans, Network Coordination Center, RIPNCC, for Europe, the Middle East, and Central Asia were delegated to assign IP address blocks and other Internet parameters to local registries, such as Internet service providers, from a designated pool of addresses set aside for each region. The National Telecommunications and Information Administration, an agency of the United States Department of Commerce, had final approval over changes to the DNS root zone until the IANA stewardship transition on October 1, 2016. 54, 55, 56, 57. The Internet Society, ISOC, was founded in 1992 with a mission to assure the open development, evolution and use of the Internet for the benefit of all people throughout the world. 58. Its members include individuals, anyone may join, as well as corporations, organizations, governments, and universities. Among other activities, ISOC provides an administrative home for a number of less formally organized groups that are involved in developing and managing the Internet, including the IETF, Internet Architecture Board, IAB, Internet Engineering Steering Group, IESG, Internet Research Task Force, IRTF, and Internet Research Steering Group, IRSG. On November 16, 2005, the United Nations-sponsored World Summit on the Information Society in Tunis established the Internet Governance Forum, IGF, to discuss Internet-related issues. Infrastructure. See also, List of countries by number of Internet users and List of countries by Internet connection speeds. 2007 map showing submarine fiber optic telecommunication cables around the world. The communications infrastructure of the Internet consists of its hardware components and a system of software layers that control various aspects of the architecture. As with any computer network, the Internet physically consists of routers, media, such as cabling and radio links, repeaters, modems etc. However, as an example of internetworking, many of the network nodes are not necessarily Internet equipment per se. The Internet packets are carried by other full-fledged networking protocols, with the Internet acting as a homogeneous networking standard, running across heterogeneous hardware, with the packets guided to their destinations by IP routers. Service tiers. Packet routing across the Internet involves several tiers of Internet service providers. Internet service providers, ISPs, establish the worldwide connectivity between individual networks at various levels of scope. End users who only access the Internet when needed to perform a function or obtain information, represent the bottom of the routing hierarchy. At the top of the routing hierarchy are the Tier 1 networks, large telecommunication companies that exchange traffic directly with each other via very high-speed fiber optic cables and governed by peering agreements. Tier 2 and lower-level networks buy Internet transit from other providers to reach at least some parties on the global Internet, though they may also engage in peering. An ISP may use a single upstream provider for connectivity, or implement multi-arming to achieve redundancy and load balancing. Internet exchange points are major traffic exchanges with physical connections to multiple ISPs. Large organizations, such as academic institutions, large enterprises, and governments, may perform the same function as ISPs, engaging in peering and purchasing transit on behalf of their internal networks. Research networks tend to interconnect with large subnetworks such as Giant, Gloriad, Internet2, and the UK's National Research and Education Network, JANET. Access. Common methods of Internet access by users include dial-up with a computer modem via telephone circuits, broadband over coaxial cable, fiber optics or copper wires, Wi-Fi, satellite, and cellular telephone technology, for example 3G, 4G. The Internet may often be accessed from computers in libraries and Internet cafes. Internet access points exist in many public places such as airport halls and coffee shops. Various terms are used, such as public Internet kiosk, public access terminal, and web payphone. Many hotels also have public terminals that are usually fee-based. These terminals are widely accessed for various usages, such as ticket booking, bank deposit, or online payment. Wi-Fi provides wireless access to the Internet via local computer networks. Hotspots providing such access include Wi-Fi cafes, where users need to bring their own wireless devices such as a laptop or PDA. These services may be free to all, free to customers only, or fee-based. Grassroots efforts have led to wireless community networks. Commercial Wi-Fi services that cover large areas are available in many cities, such as New York, London, Vienna, Toronto, San Francisco, Philadelphia, Chicago, and Pittsburgh, where the internet can then be accessed from places such as a park bench. 59. Experiments have also been conducted with proprietary mobile wireless networks like Ricochet, various high-speed data services over cellular networks, and fixed wireless services. Modern smartphones can also access the internet through the cellular carrier network. For web browsing, these devices provide applications such as Google Chrome, Safari, and Firefox, and a wide variety of other internet software may be installed from app stores. Internet usage by mobile and tablet devices exceeded desktop worldwide for the first time in October 2016. 60. Mobile communication. Number of mobile cellular subscriptions 2012 to 2016. World Trends in Freedom of Expression and Media Development Global Report 2017-2018. The International Telecommunication Union, ITU, estimated that, by the end of 2017, 48% of individual users regularly connect to the Internet, up from 34% in 2012. 61. Mobile Internet connectivity has played an important role in expanding access in recent years, especially in Asia and the Pacific and in Africa. 62. The number of unique mobile cellular subscriptions increased from 3.89 billion in 2012 to 4.83 billion in 2016, two-thirds of the world's population, with more than half of subscriptions located in Asia and the Pacific. The number of subscriptions is predicted to rise to 5.69 billion users in 2020. 63. As of 2016, almost 60% of the world's population had access to a 4G broadband cellular network, up from almost 50% in 2015 and 11% in 2012. Discuss 63. The limits that users face on accessing information via mobile applications coincide with a broader process of fragmentation of the Internet. Fragmentation restricts access to media content and tends to affect poorest users the most. 62. Zero rating, the practice of Internet service providers allowing users free connectivity to access specific content or applications without cost, has offered opportunities to surmount economic hurdles, but has also been accused by its critics as creating a two-tiered Internet. To address the issues with zero rating, an alternative model has emerged in the concept of equal rating and is being tested in experiments by Mozilla and Orange in Africa. Equal rating prevents prioritization of one type of content and zero rates all content up to a specified data cap. A study published by Chatham House, 15 out of 19 countries researched in Latin America had some kind of hybrid or zero-rated product offered. Some countries in the region had a handful of plans to choose from, across all mobile network operators, while others, such as Colombia, offered as many as 30 prepaid and 34 postpaid plans. 64. A study of 8 countries in the Global South found that zero-rated data plans exist in every country, although there is a great range in the frequency with which they are offered and actually used in each. 65. The study looked at the top 3 to 5 carriers by market share in Bangladesh, Colombia, Ghana, India, Kenya, Nigeria, Peru, and Philippines. Across the 181 plans examined, 13% were offering zero-rated services. Another study, covering Ghana, Kenya, Nigeria, and South Africa, found Facebook's Free Basics and Wikipedia Zero to be the most commonly zero-rated content. 66. Internet Protocol Suite. Internet Protocol Suite. Application Layer. BGP DHCP v6 DNS FTP HTTP HTTPS IMAP DAP MGCP MQTT NTP NTP OSPF POP PTP ONC/RPC RTP RTSP RIP SIP SMTP SNMP SSH Telnet TLS/SSL XMPP More. Transport Layer. TCP UDP DCCP SCTP RSVP More. Internet Layer. IP. IP4 IP6 ICMP, v6, ECNIGMPPSC more. Link layer. ARP-NDP tunnels. L2TP-PPP MAC. Ethernet Wi-Fi DSL ISDN FDDI. More. The Internet standards describe a framework known as the Internet Protocol Suite, also called TCP/IP, based on the first two components. This is a suite of protocols that are ordered into a set of four conceptual layers by the scope of their operation, originally documented in RFC 1122 and RFC 1123. At the top is the application layer, where communication is described in terms of the objects or data structures most appropriate for each application. For example, a web browser operates in a client-server application model and exchanges information with the Hypertext Transfer Protocol, HTTP, and an application-germane data structure, such as the Hypertext Markup Language, HTML. Below this top layer, the transport layer connects applications on different hosts with a logical channel through the network. It provides this service with a variety of possible characteristics, such as ordered, reliable delivery, TCP, and an unreliable datagram service, UDP. Underlying these layers are the networking technologies that interconnect networks at their borders and exchange traffic across them. The Internet layer implements the Internet Protocol, IP, which enables computers to identify and locate each other by IP address, and route their traffic via intermediate, transit, networks. 67. The Internet Protocol layer code is independent of the type of network that it is physically running over. At the bottom of the architecture is the link layer, which connects nodes on the same physical link, and contains protocols that do not require routers for traversal to other links. The protocol suite does not explicitly specify hardware methods to transfer bits, or protocols to manage such hardware, but assumes that appropriate technology is available. Examples of that technology include Wi-Fi, Ethernet, and DSL. As user data is processed through the protocol stack, each abstraction layer adds encapsulation information at the sending host. Data is transmitted over the wire at the link level between hosts and routers. Encapsulation is removed by the receiving host. Intermediate relays update link encapsulation at each hop, and inspect the IP layer for routing purposes. Internet Protocol. Conceptual data flow in a simple network topology of two hosts, A and B, connected by a link between their respective routers. The application on each host executes read and write operations as if the processes were directly connected to each other by some kind of data pipe. After the establishment of this pipe, most details of the communication are hidden from each process, as the underlying principles of communication are implemented in the lower protocol layers. In analogy, at the transport layer the communication appears as host to host, without knowledge of the application data structures and the connecting routers, while at the internetworking layer, individual network boundaries are traversed at each router. The most prominent component of the Internet model is the Internet Protocol, IP. IP enables internetworking and, in essence, establishes the Internet itself. Two versions of the Internet Protocol exist, IPv4 and IPv6. IP addresses. A DNS resolver consults three name servers to resolve the domain name user visible www.wikipedia.org to determine the IPv4 address 207.142.131.234. For locating individual computers on the network, the Internet provides IP addresses. IP addresses are used by the Internet infrastructure to direct Internet packets to their destinations. They consist of fixed-length numbers, which are found within the packet. IP addresses are generally assigned to equipment either automatically via DHCP, or are configured. However, the network also supports other addressing systems. Users generally enter domain names, for example n.wikipedia.org, instead of IP addresses because they are easier to remember. They are converted by the domain name system, DNS, into IP addresses which are more efficient for routing purposes. IPv4. Internet Protocol version 4, IPv4, defines an IP address as a 32-bit number. 67, IPv4 is the initial version used on the first generation of the Internet and is still in dominant use. It was designed to address up to 4.3 billion, 109, hosts. However, the explosive growth of the Internet has led to IPv4 address exhaustion, which entered its final stage in 2011, 68, when the global IPv4 address allocation pool was exhausted. IPv6. Because of the growth of the Internet and the depletion of available IPv4 addresses, a new version of IPv6 was developed in the mid-1990s, which provides vastly larger addressing capabilities and more efficient routing of Internet traffic. IPv6 uses 128 bits for the IP address and was standardized in 1998. 69 70 71, IPv6 deployment has been ongoing since the mid-2000s and is currently in growing deployment around the world, since Internet Address Registries, IRS, began to urge all resource managers to plan rapid adoption and conversion. 72. IPv6 is not directly interoperable by design with IPv4. In essence, it establishes a parallel version of the Internet not directly accessible with IPv4 software. Thus, translation facilities must exist for internetworking or nodes must have duplicate networking software for both networks. Essentially all modern computer operating systems support both versions of the Internet protocol. Network infrastructure, however, has been lagging in this development. Aside from the complex array of physical connections that make up its infrastructure, the Internet is facilitated by bi- or multilateral commercial contracts, for example, peering agreements, and by technical specifications or protocols that describe the exchange of data over the network. Indeed, the Internet is defined by its interconnections and routing policies. Subnetwork. Creating a subnet by dividing the host identifier. A subnetwork or subnet is a logical subdivision of an IP network. 73, 1, 16 The practice of dividing a network into two or more networks is called subnetting. Computers that belong to a subnet are addressed with an identical most significant bit group in their IP addresses. This results in the logical division of an IP address into two fields, the network number or routing prefix and the rest field or host identifier. The rest field is an identifier for a specific host or network interface. The routing prefix may be expressed in classless interdomain routing (CIDR) notation written as the first address of a network, followed by a slash character, slash, and ending with the bit length of the prefix. For example, 198.51.100.024 is the prefix of the Internet Protocol version 4 network starting at the given address, having 24 bits allocated for the network prefix, and the remaining 8 bits reserved for host addressing. Addresses in the range 198.51.100.0 to 198.51.100.255 belong to this network. The IPv6 address specification 2001:DB8:/32 is a large address block with 296 addresses, having a 32-bit routing prefix. For IPv4, a network may also be characterized by its subnet mask or netmask, which is the bit mask that when applied by a bitwise AND operation to any IP address in the network, yields the routing prefix. Subnet masks are also expressed in decimal notation like an address. For example, 255.255.255.0 is the subnet mask for the prefix 198.51.100.024. Traffic is exchanged between subnetworks through routers when the routing prefixes of the source address and the destination address differ. A router serves as a logical or physical boundary between the subnets. The benefits of subnetting an existing network vary with each deployment scenario. In the address allocation architecture of the Internet using CIDR and in large organizations, it is necessary to allocate address space efficiently. Subnetting may also enhance routing efficiency, or have advantages in network management when subnetworks are administratively controlled by different entities in a larger organization. Subnets may be arranged logically in a hierarchical architecture, partitioning an organization's network address space into a tree-like routing structure. Routing. Computers and routers use routing tables in their operating system to direct IP packets to reach a node on a different subnetwork. Routing tables are maintained by manual configuration or automatically by routing protocols. End nodes typically use a default route that points toward an ISP providing transit, while ISP routers use the border gateway protocol to establish the most efficient routing across the complex connections of the global Internet. The default gateway is the node that serves as the forwarding host, router, to other networks when no other route specification matches the destination IP address of a packet. 7475. IETF. While the hardware components in the Internet infrastructure can often be used to support other software systems, it is the design and the standardization process of the software that characterizes the Internet and provides the foundation for its scalability and success. The responsibility for the architectural design of the Internet software systems has been assumed by the Internet Engineering Task Force, IETF. 76. The IETF conducts standard-setting work groups, open to any individual, about the various aspects of Internet architecture. The resulting contributions and standards are published as request for comments, RFC, documents on the IETF website. The principal methods of networking that enable the Internet are contained in specially designated RFCs that constitute the Internet standards. Other less rigorous documents are simply informative, experimental, or historical, or document the best current practices, BCP, when implementing Internet technologies. Applications and services. The Internet carries many applications and services, most prominently the World Wide Web, including social media, electronic mail, mobile applications, multiplayer online games, Internet telephony, file sharing, and streaming media services. Most servers that provide these services are today hosted in data centers, and content is often accessed through high-performance content delivery networks. World Wide Web. Main article, World Wide Web. This NeXT computer was used by Tim Berners-Lee at CERN and became the world's first web server. The World Wide Web is a global collection of documents, images, multimedia, applications, and other resources, logically interrelated by hyperlinks and referenced with uniform resource identifiers, URIs, which provide a global system of named references. URIs symbolically identify services, web servers, databases, and the documents and resources that they can provide. Hypertext Transfer Protocol, HTTP, is the main access protocol of the World Wide Web. Web services also use HTTP for communication between software systems for information transfer, sharing and exchanging business data and logistic, and is one of many languages or protocols that can be used for communication on the Internet. 77. World Wide Web browser software, such as Microsoft's Internet Explorer, Edge, Mozilla Firefox, Opera, Apple's Safari, and Google Chrome, lets users navigate from one web page to another via the hyperlinks embedded in the documents. These documents may also contain any combination of computer data, including graphics, sounds, text, video, multimedia, and interactive content that runs while the user is interacting with the page. Client-side software can include animations, games, office applications, and scientific demonstrations. Through keyword-driven Internet research using search engines like Yahoo, Bing, and Google, users worldwide have easy, instant access to a vast and diverse amount of online information. Compared to printed media, books, encyclopedias, and traditional libraries, the World Wide Web has enabled the decentralization of information on a large scale. The web has enabled individuals and organizations to publish ideas and information to a potentially large audience online at greatly reduced expense and time delay. Publishing a web page, a blog, or building a website involves little initial cost and many cost-free services are available. However, publishing and maintaining large, professional websites with attractive, diverse and up-to-date information is still a difficult and expensive proposition. Many individuals and some companies and groups use weblogs or blogs, which are largely used as easily updatable online diaries. Some commercial organizations encourage staff to communicate advice in their areas of specialization in the hope that visitors will be impressed by the expert knowledge and free information, and be attracted to the corporation as a result. Advertising on popular web pages can be lucrative, and e-commerce, which is the sale of products and services directly via the web, continues to grow. Online advertising is a form of marketing and advertising which uses the internet to deliver promotional marketing messages to consumers. It includes email marketing, search engine marketing, SEM, social media marketing, many types of display advertising, including web banner advertising, and mobile advertising. In 2011, Internet advertising revenues in the United States surpassed those of cable television and nearly exceeded those of broadcast television. 78.19 Many common online advertising practices are controversial and increasingly subject to regulation. When the web developed in the 1990s, a typical web page was stored in completed form on a web server, formatted in HTML. Complete for transmission to a web browser in response to a request. Over time, the process of creating and serving web pages has become dynamic, creating a flexible design, layout, and content. Websites are often created using content management software with, initially, very little content. Contributors to these systems, who may be paid staff, members of an organization or the public, fill underlying databases with content using editing pages designed for that purpose while casual visitors view and read this content in HTML form. There may or may not be editorial, approval and security systems built into the process of taking newly entered content and making it available to the target visitors. Communication. Email is an important communications service available via the Internet. The concept of sending electronic text messages between parties, analogous to mailing letters or memos, predates the creation of the Internet. 7980 Pictures, documents, and other files are sent as email attachments. Email messages can be CC'd to multiple email addresses. Internet telephony is a common communications service realized with the Internet. The name of the principal Internet working protocol, the Internet Protocol, lends its name to Voice over Internet Protocol, VoIP. The idea began in the early 1990s with walkie-talkie-like voice applications for personal computers. VoIP systems now dominate many markets, and are as easy to use and as convenient as a traditional telephone. The benefit has been substantial cost savings over traditional telephone calls, especially over long distances. Cable, ADSL, and mobile data networks provide Internet access in customer premises 81, and inexpensive VoIP network adapters provide the connection for traditional analog telephone sets. The voice quality of VoIP often exceeds that of traditional calls. Remaining problems for VoIP include the situation that emergency services may not be universally available, and that devices rely on a local power supply, while older traditional phones are powered from the local loop, and typically operate during a power failure. Data transfer. File sharing is an example of transferring large amounts of data across the Internet. A computer file can be emailed to customers, colleagues and friends as an attachment. It can be uploaded to a website or file transfer protocol, FTP, server for easy download by others. It can be put into a shared location or onto a file server for instant use by colleagues. The load of bulk downloads to many users can be eased by the use of mirror servers or peer-to-peer networks. In any of these cases, access to the file may be controlled by user authentication. The transit of the file over the Internet may be obscured by encryption, and money may change hands for access to the file. The price can be paid by the remote charging of funds from, for example, a credit card whose details are also passed, usually fully encrypted, across the Internet. The origin and authenticity of the file received may be checked by digital signatures or by MD5 or other message digests. These simple features of the Internet, over a worldwide basis, are changing the production, sale, and distribution of anything that can be reduced to a computer file for transmission. This includes all manner of print publications, software products, news, music, film, video, photography, graphics and the other arts. This in turn has caused seismic shifts in each of the existing industries that previously controlled the production and distribution of these products. Streaming media is the real-time delivery of digital media for the immediate consumption or enjoyment by end users. Many radio and television broadcasters provide Internet feeds of their live audio and video productions. They may also allow time-shift viewing or listening such as preview, classic clips and listen again features. These providers have been joined by a range of pure Internet broadcasters who never had on-air licenses. This means that an Internet-connected device, such as a computer or something more specific, can be used to access online media in much the same way as was previously possible only with a television or radio receiver. The range of available types of content is much wider, from specialized technical webcasts to on-demand popular multimedia services. Podcasting is a variation on this theme, where, usually audio, material is downloaded and played back on a computer or shifted to a portable media player to be listened to on the move. These techniques using simple equipment allow anybody, with little censorship or licensing control, to broadcast audio-visual material worldwide. Digital media streaming increases the demand for network bandwidth. For example, standard image quality needs 1 megabit per second link speed for SD 480p, HD 720p quality requires 2.5 megabits per second, and the top-of-the-line HDX quality needs 4.5 megabits per second for 1080p. 82. Webcams are a low-cost extension of this phenomenon. While some webcams can give full frame rate video, the picture either is usually small or updates slowly. Internet users can watch animals around an African waterhole, ships in the Panama Canal, traffic at a local roundabout or monitor their own premises, live and in real time. Video chat rooms and video conferencing are also popular with many uses being found for personal webcams, with and without two-way sound. YouTube was founded on February 15, 2005 and is now the leading website for free streaming video with more than 2 billion users. 83. It uses an HTML5-based web player by default to stream and show video files. 84. Registered users may upload an unlimited amount of video and build their own personal profile. YouTube claims that its users watch hundreds of millions, and upload hundreds of thousands of videos daily. Social impact. The Internet has enabled new forms of social interaction, activities, and social associations. This phenomenon has given rise to the scholarly study of the sociology of the Internet. Users. See also, Global Internet usage, English in computing, and languages used on the Internet. Share of population using the Internet. 85. See or edit source data. A scatter plot showing Internet usage per capita versus GDP per capita. It shows Internet usage increasing with GDP. Internet users per 100 population members and GDP per capita for selected countries. Internet users per 100 inhabitants. Source: International Telecommunication Union. 86-87. From 2000 to 2009, the number of Internet users globally rose from 394 million to 1.858 billion. 88. By 2010, 22% of the world's population had access to computers with 1 billion Google searches every day, 300 million Internet users reading blogs, and 2 billion videos viewed daily on YouTube. 89. In 2014 the world's Internet users surpassed 3 billion or 43.6% of world population, but two-thirds of the users came from richest countries, with 78.0% of Europe countries' population using the Internet, followed by 57.4% of the Americas. 90, however, by 2018, Asia alone accounted for 51% of all Internet users, with 2.2 billion out of the 4.3 billion Internet users in the world coming from that region. The number of China's Internet users surpassed a major milestone in 2018, when the country's Internet Regulatory Authority, China Internet Network Information Center, announced that China had 802 million Internet users. 91. By 2019, China was the world's leading country in terms of Internet users, with more than 800 million users, followed closely by India, with some 700 million users, with the United States a distant third with 275 million users. However, in terms of penetration, China has won a 38.4% penetration rate compared to India's 40% and the United States' 80%. 92. As of 2020, it was estimated that 4.5 billion people use the Internet, more than half of the world's population. 93-94. The prevalent language for communication via the Internet has always been English. This may be a result of the origin of the Internet, as well as the language's role as a lingua franca and as a world language. Early computer systems were limited to the characters in the American Standard Code for Information Interchange, ASCII, a subset of the Latin alphabet. After English, 27%, the most requested languages on the World Wide Web are Chinese, 25%, Spanish, 8%, Japanese, 5%, Portuguese and German, 4% each, Arabic, French and Russian, 3% each, and Korean, 2%. 95. By region, 42% of the world's Internet users are based in Asia, 24% in Europe, 14% in North America, 10% in Latin America and the Caribbean taken together, 6% in Africa, 3% in the Middle East and 1% in Australia/Oceania. 96. The Internet's technologies have developed enough in recent years, especially in the use of Unicode, that good facilities are available for development and communication in the world's widely used languages. However, some glitches such as mojibake, incorrect display of some languages' characters, still remain. In an American study in 2005, the percentage of men using the Internet was very slightly ahead of the percentage of women, although this difference reversed in those under 30. Men logged on more often, spent more time online, and were more likely to be broadband users, whereas women tended to make more use of opportunities to communicate, such as email. Men were more likely to use the Internet to pay bills, participate in auctions, and for recreation such as downloading music and videos. Men and women were equally likely to use the Internet for shopping and banking. 97. More recent studies indicate that in 2008, women significantly outnumbered men on most social networking services, such as Facebook and MySpace, although the ratios varied with age. 98. In addition, women watched more streaming content, whereas men downloaded more. 99. In terms of blogs, men were more likely to blog in the first place. Among those who blog, men were more likely to have a professional blog, whereas women were more likely to have a personal blog. 100. Splitting by country, in 2012 Iceland, Norway, Sweden, the Netherlands, and Denmark had the highest Internet penetration by the number of users, with 93% or more of the population with access. 101. Several neologisms exist that refer to Internet users. Netizen, as in citizen of the net. 102, refers to those actively involved in improving online communities, the Internet in general or surrounding political affairs and rights such as free speech. 103-104, Internet refers to operators or technically highly capable users of the Internet. 105-106, digital citizen refers to a person using the Internet in order to engage in society, politics, and government participation. 107. Internet users by language 95. Website content languages 108. Usage. Internet users in 2015 as a percentage of a country's population. Source: International Telecommunication Union. 101. Main articles: Global Digital Divide and Digital Divide. Fixed broadband internet subscriptions in 2012. As a percentage of a country's population. Source: International Telecommunication Union. 109. Mobile broadband internet subscriptions in 2012. As a percentage of a country's population. Source: International Telecommunication Union. 110. The Internet allows greater flexibility in working hours and location, especially with the spread of unmetered high-speed connections. The Internet can be accessed almost anywhere by numerous means, including through mobile Internet devices. Mobile phones, data cards, handheld game consoles and cellular routers allow users to connect to the Internet wirelessly. Within the limitations imposed by small screens and other limited facilities of such pocket-sized devices, the services of the Internet, including email and the web, may be available. Service providers may restrict the services offered and mobile data charges may be significantly higher than other access methods. Educational material at all levels from preschool to postdoctoral is available from websites. Examples range from KBBs, through school and high school revision guides and virtual universities, to access to top-end scholarly literature through the likes of Google Scholar. For distance education, help with homework and other assignments, self-guided learning, whiling away spare time or just looking up more detail on an interesting fact, it has never been easier for people to access educational information at any level from anywhere. The Internet in general and the World Wide Web in particular are important enablers of both formal and informal education. Further, the Internet allows universities, in particular, researchers from the social and behavioral sciences, to conduct research remotely via virtual laboratories, with profound changes in reach and generalizability of findings as well as in communication between scientists and in the publication of results. 111.